In this example, I'm looking at expanding each of these expressions here. Now each of these expressions is of the form where we can use the difference of two squares rule. And the difference of two squares rule states that if we have a plus b times a minus b, then we can expand that out to be just a squared minus b squared. So if we have a look at part A, where we have x plus 1 times x minus 1. If we apply our difference of two squares rule to this, we take our first term and square it, so x squared, and then we take our second term, which is 1, just the number, and we subtract it off and square it. So we have x squared minus 1. Then if we look at part B, we have x plus 4 times x minus 4. So again, if we apply our rule, we take our first term, which is the first term in the brackets, x, and we square it, so we have x squared, and then we subtract off the second number, or the second term squared, which in this case is 4, and we square it. So we have x squared minus 16. If we have a look at part C, we have 6 minus x times 6 plus x. Now I know the rule for the difference of two squares is a plus b times a minus b, and over here we have minus followed by plus. This doesn't matter, we can have these in any order. We still follow the same process. We take the first term, which in this case is 6, and we square it, and we subtract off the second term, which is now x, and we square it. So now we write this out, we have 6 squared is 36 minus x squared. And then lastly, part D, we have 2x minus 3 times 2x plus 3. So again, if we apply this process to this, we get our first term squared, so our first term is now 2x, and we square it, so the whole thing is squared, and we subtract off our last term squared, which is now 3. So we're going to take our 2 squared, which is 4, and an x squared is x squared minus of 3 squared, which is 9.